Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. So, we continue our lecture for chapters on sensors. What type of sensors that will be useful for us to design a certain medical instrumentation measurement tools. Okay. To start off with, in this diagram, you can see this nice sensor is connected to the breadboard, and there is a finger pressing the side which has the printed circuits that is connected to two tips at the end. So by pressing here, there is a reading will be detected. So there is some changes will happen. This sensor is called Fos sensitive resistor. So basically, students, they use it so much in their projects, final projects. So it's Fos sensor. They just simply call it Fos sensor, but the full name is Fos sensitive resistor. What's the function of this Fos sensor? It detects physical pressure, squeezing, and weight. So they are simple to use, low cost. Yeah, it's quite cheap. The sensor is Interlink model 402 FSR with half diameter sensing region. Right. So the readings that come out is, since this is it measures in the force, so the output produced is in as a resistor. So we can imagine the output will be in resistance, and then the unit will be in ohms, depending on how much is pressed. I mean, changes is resistive value depending on how much is pressed. So easy to use. They are really accurate. They also very some from sensor to sensor, perhaps 10%. It's quite challenging also to get them working. Sometimes you will find the difficulties in getting a stable output, so you need to adjust them with variable resistor as well. When you use FSR, you should only expect to get range of response. The FSR can detect weight. They are bad choice for detecting exactly how many pounds of weight are on them. That means you need to identify a specific range that you want to measure, and then you have to plot them to find out they fall under which category or which weightage level. So they are made of plastic, and the connection tab is cream on delicate material. The best way to connect to this is to simply plug them into breadboard, clamp style connector like alligator clips, female header, terminal blocks. Possible to solder, but you must be very fast, because if your iron is not good quality or delay even a few seconds, you'll melt the plastic and ruin the FSR. So that means it's quite sensitive as well. Now that's one example which you can measure the force. Another one that is useful, which I find useful in the medical instrumentation, is flex sensor, as its is named. So you can see there's fingers which is bending the flex sensor. So it has the same two connection tip, and then it's can be flexed down to 90 degrees. So flex sensor are passive resistors device that can be used to detect bending or flexing. The flex sensor also available in bidirectional flex sensor that decreases its resistance in proportion to the amount it is bent either direction. So both direction it works. That's why it's called bidirection. Application: flex sensor may be used in robotics to determine joint movement. Yeah, this is what you have to focus for today's lesson. Joint movement of placement, used like whiskers for wall detection. Sensors are also pressure sensitive, so they can be also used as bumper switches for wall detection, pressure switches, robotic grippers, biometrics. Can be used on moving joint of athletic equipments to provide an electrical indication of movement or placement. A few of the sensors can be incorporated onto a glove to make virtual reality glove, right? So that means inside the glove you can place this flex sensor. Let's say in the glove we have 5 slots for 5 fingers, so each finger is fixed with one flex sensor, so you will have 5 flex sensor inside the glove, which is connected to a system that measures every time you have the what we call gripping activities, opening the hands, so there's a reading being taken. Or for example, use positioning at the site in the joints or muscles where there is great movement, so the movement is high. So for example, if you take the hand, of course, so in the hand, which side will be most suitable to put the flex sensor? I'll give you an idea. For example, the elbow. Okay. For example, they've used flex sensor for biometric application. Sensor can be placed on a moving joint of athletic equipment. Later I'll give you the example that I'll promise to show you. Equipment provide an electrical indication, movement or placement. So, and then this gloves one, to make it clear, I'll show you in the form of a figure later on. So let's move on. That's 2 sensors already we covered. The third one, which is quite important in the medical instrumentation or biomedical or in the signal monitoring application, I'm sure you know already, it's called accelerometer. So as its name stands, accelerometer, you know that the function is to measure the acceleration forces. It's an electromechanical device to measure acceleration forces. Forces may be static at the continuous force of gravity, as in the case with many mobile devices, dynamic to sense movement or vibration. Acceleration is the measurement of change in velocity or speed divided by time. Let's take one example. In the phone nowadays, so our smartphone, there are available few types of application. For example, you have you can measure how many steps taken daily. So towards the end of the day, it will tell you that how many steps you have taken for that day. So how it's actually done is there's an accelerometer present in the phone, and when the phone is in the pocket or when you're walking with the phone on your hand, so basically when you're swinging your legs and hands, it is actually detecting the patterns of your walking. So at the same time, it is also collecting the data of how many steps that you have taken. So at the end of the day, it will count all the swingings that have been done by the while walking, so it will let you know how many steps are taken, right? What is the use of accelerometer in mobile phone for other tasks is so field takes into account the presence of accelerometer, gyroscope, compass, and the barometer. Accelerometer in mobile phone are used to detect orientation of the phone. That's another one. So for example, you are checking the Qiblat direction, so you will first need to calibrate the compass. So you calibrate the compass, and then you will put in the right coordinate, and then you are able to detect. What else? Gyroscope, something similar. It has to do with the what we call balancing and also movement. Right, accelerometer, multiple application in industry and science. Highly sensitivity accelerometer are components of inertial navigation system for aircraft and missiles. So you can check the detonation of one of the aircraft missiles. For example, when you shoot the missile, so there is an acceleration force be measured, and then you can also identify the process. That means the takeoff speed and then current positioning. So all through these sensors. Accelerometer are used in tablet computers, digital cameras, and that images on screen display upright. So in a simple way, you can see, you're using your phone in the portrait mode. Suddenly you move it to landscape mode, so you can see the screen become wider. So that's also something to do with accelerometers. So it's positioning, checking the signals or the input data coming in X, Y, and Z direction. By computing the X, Y, Z direction data, so you'll be able to tell whether you have to switch the screen into landscape mode or portrait mode. Accelerometer are used in drones, flight stabilization. Okay, so drones, nowadays people are very much incorporated into drone application. So how to stabilize the drone? Nowadays you have the button for drone stabilization, auto stabilization for flights. Coordinate accelerometer can be used to measure difference in proper acceleration, particularly gravity over their separation, right? So gyroscope is another sensors as well. Gyro are devices that measure and maintain rotational motion. Rotational motion is a little bit different with the accelerometer. It's a MEMS based. Gyros are small, micro size, micro electromechanical system. So its combination, the measurement is combined with electro and mechanical. That means electrical or electronic combined with mechanical system. Micro means the chip is too small. Inexpensive sensor that measures angular velocity. The units of angular velocity measured in degrees per second or revs per second, revolutions. So that means if you have fixed it on the person, so the running, so it can actually measure the rotational speed, right? Now let's look at some focused application in biology. Accelerometers are used by researchers in biological science. So high frequency recording of bi or triaxial acceleration allows the discrimination of behavioral patterns while animals are out of sight. That means when you have the animals cut loose or you release an animal, the researchers nowadays, they can look at their what we call expanding energy in the wild, their patterns, how they will introduce, how they survive, and where do they travel. This is all by either determination of limb stroke frequency, measures such as dynamic body acceleration. So these two, So when they move, they are free in the wild. So the researchers are able to track them, monitor their signal. Such approaches have mostly been adopted by marine scientists due to inability to study animal in the wild using visual observation. Right? So if you have what we call, let's say, dolphin, so you want to follow that dolphin, then you are able to fix them with an accelerometer, or for example, even gyroscope to measure their behavioral patterns in the sea, in the ocean. This device can be connected to an amplifier to amplify the signal. That's the usual one. Okay. This one is types of application in the medicals, but there are so many. Not just that, Zol AED Plus uses CPR D-pads which contain accelerometer to measure the depth of CPR chest compression. Right? Within the last several years, several companies produce and market sport watches for runners that include footprints containing accelerometers to help determine the speed, distance the runner wearing the unit. Okay, that's another example. In Belgium, accelerometer-based step counters promoted by the government to encourage people to walk a few thousand steps each day. So that means that's the initiative by the government to make sure the people are healthy, so they have to walk few steps. So this is also can be monitored by the accelerometer. Another companies uses accelerometer to measure strike force in physical training. So that means you use them to monitor during a person's training, whatever is the training. It has also been suggested to build football helmets. So inside the helmets, you basically position the accelerometer in order to measure the impact of head collision. Sebab orang main bola ni kan banyak orang kata apa, injury ataupun banyak hentakan di kepala. Jadi bolehlah kita monitor berapa hentakan, apa ni, kekuatan hentakan tu, impact tu menyebabkan seseorang tu jatuh ataupun dia pengsan dan sebagainya. So to measure the head collision, accelerometer have been used to calculate gait parameters. Gait parameter apa? Macam kaki lah, swinging, berjalan, such as stance, swing, pace. This kind of sensor can be used to measure or monitor people's not monitor people, but to monitor the movement of the people. Alright. Okay, selepas tengok kuliah ni, harap semua akan buat sikit revision, mendalami maklumat-maklumat yang diperlukan untuk beberapa sensors yang saya dah mention tadi: flex, force, accelerometer, gyroscope. Okay, so you find out some more information. And then I'm also mentioning one question. So how does a missile function? By following a target. So this is something to trigger your thinking level. So you know, in a missile, so sometimes when the flight or the aim which is locked on the people in front, so the missile will follow the target until it destroy or it is explode the flight, for example. So inside a missile, what is the sensors that use to follow this target? Okay, you can type the answer in the comment section after the video. After you watch the video, go and do some revision and find out some answer, and then type your answer with your name as well, so I know who's answering. Right? It is an interesting one to know. Okay, now this is one problem statement that I'm giving to all the students. This is the problem statement that I'm giving to all the students. First, just let us see what's the problem actually. how can you help a half body paralyzed subject? That means this person is paralyzed. So normally there's paralyzed like mild stroke, half body stroke, right, or full body stroke, or the stroke is up to the neck, right? This is a paraplegic subject. Okay, paraplegic, that means from the waist and below. But this one is a half body paralyzed subject whom are trying to recover his hand strength. Okay, his hand strength. So that means so he is focusing on the hand to improve, right, his strength as he slowly recover from the illness. Most of physiotherapy patients lost their interest in pursuing their routine training since unable to see the improvement. This is true. For example, if a person go for physiotherapy nowadays, the physiotherapy session is good, the person in charge is good, the session is good, but the problem is some people they don't appreciate it because they simply don't see the improvement, whereas we don't know whether there is an improvement or not because there is no measurement being done after the session. So normally people want to see numbers, figures, alright. So if they see the numbers, then they will value them. For example, if they go for physiotherapy for 3-4 weeks, so the 5th week they are able to see their improvement in terms of performance based in percentage. The improvement is based on the percentage, so they can tell the patient you have improved 10-20% of the particular body function, for example. Then it will be something motivating the person who are using it, right? So I want you to demonstrate your idea. This patient focusing on to gain ability on the hand only. So that's mean the first question is I want you to find out about hand only, right? So you how can we help this patient to improve their hand function through medical instrumentation? That's the idea. Number 2, similar to above condition, so the same condition, half body paralyzed, this patient is trying to gain ability on his leg. Okay, so there are 2 conditions. One is hand and the other one is leg. So your answer should have rational design or sensors used. That means what I mean by rational design or sensors is the positioning of sensors is really important. Reason for positioning of sensors. So you might put the sensors where? Let's look at 1 or 2 example, and then I'm sure you'll be able to complete this problem. Okay. 1, rational design, sensors used. That means you choose the sensors which I mentioned earlier, 3-4 types of sensors available. Reason for positioning of sensors. Okay. And then impact of measurement, ability to monitor. Okay, this is the hand, right? For example, if the patient is trying to recover the hand function, that means what can we do? So how can we extract the hand strength as electrical or electronic signals so that it is displaying some figures, some units in numbers, quantified measurement. I'll give you one example. Let's take this one finger. Alright, so we can place one flex sensor, for example. Okay, so where do you place the flex sensor? At the bottom or on the top of the finger? Behind. So this is the back, so the front side. So you can place. So if you place on the back of the finger, on top of the finger, then you need to know, you have to tell me what is the reason that you place on top of the finger, or in below, why in the below, and then what other sensors. For example, you can also include Fos Sensor. So where can you position the Fos Sensor? One, let's say at the end where the many activities is performed with the thumb. So you place a Fos Sensor here at the fingertip, so that every time the gripping activities, so you will be able to measure the strength of this finger. And then this one is to measure the bending of this finger. That's one example. So the rest you have to we call explore yourself. Okay, so that's if you use the hand. Let's say this one is the arm one. So I didn't show you the leg one, so let's take this arm as an example. So you need to position the sensor where there is a maximum what we call maximum movement, bendings. So therefore in our hand, for example, on the hand which side, for example, on this bulging area, the hand, where when you do the grip test, there's a maximum muscular contraction. So you can position somewhere here, and then at the elbow, this is what I promised you earlier. So at the elbow, you can include one sensors, the hand, and on the wrist. So which one is suitable? Either flex, force, or accelerometer, and then you come up with the design. So what do you aim? What do you aim to measure by positioning the sensors in the wrist, in the maximum muscular contraction area, the elbow, the hand, the arm? So you have to write them in your answer sheet. So, and then I will be able to understand the rationale. That's what I call the rationale. Reason for positioning, rational design, impact of measurement. So what you able to monitor, if you put the sensors there, what is the ability for you to monitor? So this is one part of exercise that you have to do individually. So I've given you the problem, so now you have to provide me with the solution. I mean, how do you solve the problem? And I've also given you some tips on how you can overcome or solve that problem. So hopefully you will draw a nice drawing. Let's say one page of drawing, and the second page of summarized explanation. 2 pages is enough. Not more than 2 pages. But for this one, you can use computer, Microsoft Word. So you don't have to do handwriting. So you can type the answer, so that the drawing will become better. So you can do this 2 pages. That means 2 pages for hand only, and then another 2 pages for leg. So 2 pages for hand and 2 pages for leg. So that means you will have 4 pages in total, right? And then once you have done it, you can send by email to my email address, and hopefully to put just put there as a exercise or assignment if you want, in the subject, your name, and also this title for this assignment, instrumentation design assignment. Okay, so but make sure is a creative answer, so you do it with the maximum information, but not to jumble up with so many information. So select the most appropriate one, but the main thing is we want to look at your understanding of sensors positioning, and also the rationale of the sensor being positioned, what you are able to measure. Okay, so 1 week from now, I think it should be enough. So before or on the before next lesson, so it's due on Saturday. That's all for today, and inshallah I will see you in the next lecture. Wassalamualaikum warahmatullahi wabarakatuh.